Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. Time to enter the world of civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about structural analysis hinged beam. Topic: analysis of beam with one or more hinges, internal. When designing structure, it is important to join structural members. Along their length, it is generally useful to classify such a connection, also called splice, as either a moment connection or a shear connection. See figure and flow chart. A moment splice rigidly connects the two beam segments such that the internal bending moment as well as a shear force can develop at the joint. See figure. In a shear splice, however, no bending moment can develop at the joint. The joint acts as an internal hinge. It can only support a shear force. Here we are going to learn about analysis of beam that include one or more hinges. Consider a beam. It is fixed at the left end and rests on the roller support. At the right end, the beam has an internal hinge at point C. The structure has 4 unknown support reactions. 3 at fixed end, and 1 at roller end. Although we can write 3 equilibrium equation for the entire structure, but we cannot solve them for unknown. Because we have only 3 equation but 4 unknowns. Does it mean the structure is statically indeterminate? This would have been in the case if the beam did not have an internal hinge, but the hinge at point C. Does it make the structure statically determinate? That is, we should be able to determine the support reactions solely using static equilibrium equations. Here is how the analysis of a beam with an internal hinge involves separating the beam segment at the hinge. Formulating 3 equilibrium equation for each segment, then solving them simultaneously for the unknown reaction forces. Separate beam segment. Formulate equilibrium equation. Solve for the unknown and the internal shear force at the hinge. Free body diagram of the beam. Here is the free body diagram of each beam segment. Observing, the internal shear force at the hinge is drawn at both beam segment. On the left segment, the force is shown to act downwards. On the right segment, forces are drawn upwards. These 2 arrows must always be drawn in opposing directions. And also there is an internal axial force at point C. Although most beams do not carry such forces, for completeness we need to show the force on the free body diagram. Similarly, to the internal axial force at point C, must appear in pair acting in opposite directions. Now we are going to write equilibrium equations for different beam segments. Equilibrium equation for left beam segment are summation F x equals 0. A x equals 0. Summation F y equals 0. A y minus v c equals 0. Summation m a equals 0. M plus 8v c. Equilibrium equation for right beam segment R. Summation f x equals 0 minus c x equals 0. Summation f y equals 0. V c plus b y minus 4 equals 0. Summation m c equals 0. 4 times 5 minus 10 by equals 0. Therefore we have a total of 6 equation and 6 unknown. The unknown are a x v c a y c x v y m. Solving the equations for the unknown we get, for b y summation m c equals 0. 4 times 5 minus 10b y equals 0. 0 equals 20. 10b y 10b y equals 22 knots kilonewton. 4v c summation phi equals 0. V c plus b y minus 4 equals 0 equals v c plus 2 minus 4 equals 2 knots kilonewton. 4c x summation f x equals 0 minus c x equals 0. C x equals 0. 4a x summation f x equals 0. A x equals 0. A x equals 0. 4a y summation f y equals 0. A y minus v c equals 0. A y minus 2 knots equals 0. A y equals 2 knots kilonewton. 4m summation m a equals 0. M plus 8v c m plus 8 times 2 equals 0. M equals minus 16 knots m, kilonewton meter. Summary. A x equals 0. A y equals 2 kilonewton. B y equals 2 kilonewton. C x equals 0. M equals minus 16 kilonewton meter. V C equals 2 kilonewton. Now, what happen if the beam has multiple internal hinges? How do we analyze such a beam? Here is a beam with 2 internal hinges. The beam rests on 4 supports. Supports are 1 pin support and 3 roller supports. See figure. The number of support reactions therefore is 5. We have 2 reactions at the pin support and 1 reaction at each roller support. The 2 hinges divide the beam into 3 segments. When we cut the beam segment at the hinges in effect, we are introducing 4 more unknowns. We are introducing a shear force and an axial force at each cut now. Segment 1AE, Segment 2F, Segment 3FD. Now, we have a total of 9 unknowns. There are 5 support reaction and 4 internal forces. And since we have 3 beam segments and 4 each beam segment, we can write 3 equilibrium equations. There are 9 equations, so we can solve the equations for the unknowns. Equilibrium equation for AE. Summation F x equals 0. A x plus E x equals 0. Summation F y equals 0. A y plus B y minus V E equals 0. Summation M equals 0. 7V E minus 5B y equals 0. Equilibrium equation for F. Summation F x equals 0. F x minus E x equals 0. Summation F y equals 0. V E plus C y minus V F minus 2 times 8 equals 0. Summation M E equals 0. 2 times 8 times 4 plus 8v F minus 3c Y equals 0. Equilibrium equation for AE. Summation F X equals 0 minus F X equals 0. Summation F Y equals 0 V F plus D Y equals 0. Summation M F equals 0 minus 5D Y equals 0. Now, solving the equilibrium equations for the unknowns. For value of D Y segment DF is taken. Summation M F equals 0 minus 5D Y equals 0 minus 5D Y equals 0. D Y equals 0. For value of V F summation F Y equals 0 V F plus D Y equals 0. V F plus D Y equals 0 as D Y equals 0. V F equals 0 for value of V F summation F X equals 0 minus F X equals 0. F X equals 0. For value of E X segment F is taken. Summation F X equals 0 F X minus E X equals 0 E X equals 0. For value of C Y summation M E equals 0. 2 times 8 times 4 plus 8v F minus 3c y equals 0 equals 64 plus 8 times 0 minus 3c y equals 0 equals 64 minus 3c y equals 0 64 equals 3c y c y equals 64 3 equals 21.33 kilonewton. For the value of V E summation F Y equals 0 V E plus C Y minus V F minus 2 times 8 equals 0 V E plus C Y minus V F minus 2 times 8 equals 0 V E plus 21.33 minus 0 minus 16 equals 0 V E plus 5.33 equals 0 V E equals minus 5.33 kilonewton. For the value of A X A Y V Y taking segment AE summation M equals 0 7 V E minus 5B Y equals 0 7 V E minus 5B Y equals 0 7 times minus 5.33 minus 5B Y equals 0 B Y equals 7 times minus 5.33 5 equals minus 7.49 kilonewton V Y equals minus 7.49 kilonewton. For the value of A X summation F X equals 0 A X plus E X equals 0 A X plus E X equals 0.ASE X equals 0 A X equals 0. For the value of A y summation f y equals 0 a y plus b y minus v e equals 0 a y plus b y minus v e equals 0 a y equals v e minus b y a y equals minus 5.33 minus 7.47 a y equals 2.14 kilonewton. Summary: a x equals 0 a y equals 2.14 kilonewton. B y equals minus 7.49 kilonewton. V e equals minus 5.33 kilonewton. E x equals 0 c y equals 21.33 kilonewton. D y equals 0 v f equals 0 f x equals 0. Thank you for watching.
Thank you for watching. Please subscribe to the channel and press the bell icon.